Swayam Prabha. Digital India. Educated India.
Hello friends, so we are into the week 11, the penultimate week of this MOOCs course on fundamentals of nuclear power generation, and in this week we are going to have two lectures like in the previous one, today's one and also one to follow, and over these two lectures we are going to discuss about the topic of reactor safety and security, which is something very much relevant to the modern day concepts, or also that is something like in the previous week that we have discussed about the effect of radiation on biological tissues on human being, which is something of great concern to the common people. This is also something in the same category, and also the one to follow in the next week, that is again something we are very much concerned about, the disposal of nuclear waste. So, the safety and security of nuclear power plants is of paramount importance, because whenever there is an accident in, say, in a common thermal power stations, of course there will be huge amount of loss. Depending upon the situation, there can be a significant amount of loss of life, a significant amount of loss of vegetation, and also there can be huge amount of property damage. But generally that is an one time occurrence, that is once the incident happens, the devastation will be instant and immediate, and then once we move on with time for a few days or maybe 1 month or something like that, then it will just remain as a memory, a horrible memory, that accident. But that is not particularly true for nuclear accident, because the radiation effect that any kind of radioactive nuclei contains, that always remains, whether it is inside a nuclear plant or it is somewhere outside. And therefore, whenever there is some nuclear accident happening, there is every chance that corresponding radioactive elements may get transferred to the corresponding surrounding environment, may get transferred to somewhere far, a far distance apart by the movement of wind and air or something like that. And therefore, it can not only it can hamper a huge amount of a large population and also a significant area around the plant instantaneously, but also it can have long term effect. Long means I really mean very long term effect, because some of those isotopes, like we have already seen, certain isotopes of uranium and plutonium can have extremely long half life, and therefore, if they are allowed to come out of a nuclear reactor and get transferred to the surrounding, they can keep on decaying over a very long period, thereby transferring those hazardous beta and gamma rays to the human being and also to the neighboring vegetation. That is why the safety issues of nuclear power plant is something that we need to be much more concerned about compared to any normal coal based thermal power station. In the previous week itself, we have discussed about this biological effect of radiation, and I am just repeating that thing just to illustrate what kind of effects the radioactive decay can have. We can, as we know, we can have two kinds of effects. One is the somatic effect, which is immediate and also may not be immediate actually, but it can be instantaneous. It can also span for, it can also appear after a few years, but still the same person who was exposed to radiation for at some time will be suffering from these effects, like there can be cataract if it goes into the eyes, we can have different organ failures, blood disorder, skin burn is a very common radiation damage that we can have, and even if the dose is higher, it can lead to death also. But radiation can also have very significant genetic effects, where it can cause mutation to the gene and thereby can get transferred to the next generation, thereby having a very long term effect. The congenital effects, congenital diseases can appear, premature death is also common, because it can directly affect the prenatal stage. It can directly affect during the prenatal stage as well. It can cause chromosomal abnormalities, which can lead to different kinds of genetic diseases, and the person who was exposed to radiation can get cancer in later life. In fact, that can also get transmitted to the subsequent generations. Genetic disorder subjected to not only radiation, but any kind of genetic disorder commonly are of two types. One refers to the single gene disorder, where there is only a single gene which gets muted because of radiation or because of some kind of medication or some other effect, which can lead to more than 4,000 diseases as per the present day knowledge. Single gene disorder can be passed on to the subsequent generation in several ways. However, that depends on, means how much effective it will be in the next generation, they depends on the inheritance pattern. Like you can see from this figure, we know that a common human being can have 23 chromosomes. Out of these, 22 are autosomes and 2 are sex chromosomes, which determines the which determines our gender. So, in this particular case, you can see all the chromosomes are okay, but only this 15 number one, that is having some kind of abnormality. So, this is what we refer by the single gene disorder. It can subsequently get transmitted to the next generation, causing some kind of genetic abnormalities. This is an example of the same. Like here, just be careful about the convention that we are using, or the graphical convention that I mean. Here, this particular one, this long blue bar, it refers to the Y chromosome, whereas this small blue bar refers to the X chromosome, and these are the normal copies. Now, we know that a male person contains XY chromosome, that is one X and one Y to form a pair, whereas female contains both X chromosomes. So, here we have a situation where the male is normal, who is having one normal X and one normal Y chromosome, but the female is having one normal X chromosome, but another defective copy of X chromosome, or another X chromosome with a defective gene. So, once they combine, there are 4 possible combinations we can have. Of course, we know that during the meiosis process, they will be exchanging their chromosomes, leading to the 4 possible combinations. Now, if we think about a girl, we will be getting one copy of X chromosome from the dad and one copy of X chromosome from the mom, whereas a boy will be getting one copy of X chromosome from the mom, but the Y chromosome from the dad. So, think about the think about the girls first. The girls, as they are always getting one X chromosome from the dad, so they will always be having one normal chromosome. But out of the 2 girls possible, one can have this particular X chromosome getting transmitted. So, she will continue to be a carrier of the same disease. On the contrary, for the boy, they are going to have the Y chromosome from the father, but they are going to have the X chromosome from the mother, and therefore, while one boy is going to have a normal situation, the other will get affected. As the girls are always inheriting one normal copy of the gene from their fathers, so they will either remain normal or they can become carrier, but the boy, there is every chance that they can either be normal or can get affected. On the contrary, see the situation where both the mom and dad are carrying one copy of affected X chromosome, then there is a very big problem in the next generation. Every girl is getting one X chromosome from the dad, which is already affected, that is this one, and they are also getting one X chromosome from the mom. So, it is possible that the girls will always be having one affected X chromosome which is coming from the dad, and they may get a normal chromosome from their mom, like this case, or they may get this affected chromosome. So, in this situation they will be having 2 affected X chromosomes, which definitely will affect the girl. In the case of boys, they are going to have this normal Y chromosome coming from their dad, but they are going to have either a normal X chromosome from the mom, in that case the boy will remain normal, or they are going to have this affected X chromosome from their mom, making them affected. So, in this case the girls can get affected, boys also can get affected, and the girls can also remain carrier. So, there is a 3 out of 4 possibility of the next generation being either a carrier or be getting affected by this. Therefore, genetic disorder, even in case of single genetic disorder, we can have transmission to the next generation, even as next generation can get directly affected as well. The multifactorial and polygenic disorders are where we have much more complicated and multifactorial effects, which are likely to be the effect of multiple gene in combination with the lifestyle and environmental effects. The term polygenic refers to when the result is the combined effect of multiple gene interaction, and multifactorial refers to polygenic plus some kind of environmental or lifestyle related effects. So, there can be several kinds of examples. Actually, most of them are those referred as the lifestyle diseases nowadays, like we can have diseases like diabetes or heart diseases, and also which comes from our lifestyles, and also there can be several genetically transmitted diseases such as the Alzheimer's. We can have schizophrenia kind of diseases. There can be problem related to the intelligence level, there can be problem with the height and weight of the next generation, there can be there can be mutation in the skin color or color of the eyes, etc. So, polygenic or multifactorial disorders can be much more complicated, and both the single gene and polygenic characteristics or polygenic types can be the results of radiation exposure. The effect of radiation exposure during the prenatal period can be even more devastating. There can be significant modification in the genital structure, like look at these things. This refers to Down syndrome, a quite common genetically transmitted disease, and in this case you can find trisomy in the 21th number of chromosome. Trisomy refers to instead of 2 there are 3 chromosomes, instead of having a pair we are having a triad, and this trisomy refers to trisomy in 21 chromosome, 21 slot refers to Down syndrome, where the corresponding child will be born with several defects like cleft lip or cleft palate, there can be small head, eyebrows may be absent, etc. Similarly, we can have this Edwards syndrome, which refers to trisomy in 18th number of chromosome. In this case also we have several significant effect, like there can be malformed eyes, there can be shield chest, and the back part of the skull can be very prominent like in this situation, and there are several other medical symbols which they associated. Similarly, these are just 2 examples, there can be several other cases where prenatal exposure to strong radiation can lead to trisomy of different chromosomes. Accordingly, we can have several others like Jacobson syndrome can be Jacobs syndrome or Jacobson syndrome can be other examples of such kind of things, where where we can find this trisomy in another chromosome position. So, in a nutshell, all these things could have come in the previous module only, but still I am mentioning about them in this particular module just to let you know what effect radiation can have. And here this effect of radiation can be because of any radiative source, but from now onwards we are going to focus mostly on the nuclear source, and we are not going to exclude the part related to medical radiation, radiative sources, but as a final thought there, medical radiation can also be very significant, particularly during this prenatal stage, and that is one of the reasons nowadays a pregnant woman is not suggested to go for X-rays or similar kind of therapies, because the radiation that is coming from there can significantly affect their fetus. Now, we come to the purely nuclear based accidents or incidents which led to significant radiation hazards, and of course, we have to go back to 1945 to Hiroshima. Everyone probably has seen this particular image following the bombardment or following the atomic bombing at Hiroshima on the 6th of August 1945, we saw this kind of plume formation. Huge amount of energy was released by this nuclear bomb, which was I think the name was Little Boy, and that you probably have seen these images also. This Enola Gay is the name of the aircraft which carried that little boy and dropped that on Hiroshima. This was a picture with their crew members, and Boxcar was the aircraft which carried the next one, that is a plutonium bomb towards Nagasaki on 9th of August. You probably have seen these images also. This is the route map that was followed, that is they started from this transient location at Guam, and from there this Enola Gay traveled via this particular path on 6th August, and the target was Hiroshima for this. It is quite as I do not know how to explain that, but you may know, you may not be knowing also. Hiroshima, while it was a very much planned event, Nagasaki was not all the target. Actual target was this particular place called Kokura. The event, this second bombing, the testing of that plutonium bomb, that was initially scheduled to be on 11th August, but because of some weather conditions they preponed that, brought that forward to 9th of August, and Kokura was the original target. But when the aircraft, this Boxcar that arrived to Kokura, it was unable to spot it because there was huge amount of bombing going on by the normal aircraft bombers. So, the entire town was covered with black smoke, and it was this Boxcar crew found this very difficult to spot that. There are 2 or 3 failed attempts, and after that they decided to go to the secondary target, which was Nagasaki. And so they went to Nagasaki, where this plutonium bomb called Fat Man that was disposed of, and they just about managed to come back to some kind of transit location. Actually, I can't remember clearly, but I think it was forced to make an emergency stop somewhere because it just ran out of fuel. But our target is not to have a long discussion about what happened in Hiroshima. Rather, we were looking towards what effect the radiation had in Hiroshima, and for that purpose there are several documents. There are quite a few documentaries available on internet which you can see to look into this. This is one book which was published in 2010, The Last Train from Hiroshima, The Survivors Look Back, by Charles Pellegrino. It was published in 2010, but there was lots of controversies involved with this. There are several challenges regarding the source of the data that were based on which this book was written, and later on the publisher apologized and recognized that the source of data could not be authenticated, and therefore they discontinued the publication of this one. But in 2015, I can't remember the name of that, a modified version, the second edition of this book, but with a slightly different name, that was published again by a different publisher. But the inside the cover of this book, it illustrates the story of one Japanese person called Yamaguchi, Sutomu Yamaguchi, who was one of the double explosion survivor, what you can say. Because of some kind of he was an employee of a company, and because of his official duty he went to Hiroshima, or he was at Hiroshima on that 6th August morning. On that fateful morning of 6th August, he was at Hiroshima, just about 2 kilometers from the epicenter. And then when the bomb struck, somehow he survived the event, but he saw what happened there. He was able to pass through some horrible experiences. He was able to survive through some horrible experiences, and then on the next morning, along with several other survivors of that explosion, they took a train and went back to his hometown. And what was his hometown? Incidentally, that was Nagasaki. So, he went back to Nagasaki. Then next day, after going back to Nagasaki, he next day went to the company to report the incident or the sequence of events that happened to Hiroshima. And that particular day was 9th August, when Nagasaki was under attack, and somehow he survived that one also. It is said that something like about 165% were this double attack survivor kind of thing, but Yamaguchi was the only person who was confirmed by the government of Japan to have survived both the effects. This particular book generally it rotates around it revolves around the experience that Yamaguchi and several other survivors have. It describes how Hiroshima, from a quite busy town, was transformed to a momentary version of hell among the horror. Of course, we do not want to go to the details of this, whether there is any kind of validity about the experience reported in this book, or whether it was very much exaggerated. We do not want to discuss that, but it mentions several incidents that definitely happened there. And along with, and to support that, there are several other photographic incidents are also available. One of the most horrific experiences the survivors found was something known as the ant-walking alligators, creatures of the blast that seem neither human nor animal, neither living nor dead. I do not want to show the images of that. If any of you have strong heart, you can search on internet with this term and you can find those horrific pictures. But these ant-walking alligators were referred to the persons who had been burned by the explosions to such an extent that their skin was completely taken off, their face was completely obliterated, they did not have any eyes, and their mouth was converted to just a hole. Of course, they died, but maybe after a few minutes or a few hours, it should not be hours, but maybe 30 minutes or a couple of hours. And during that period, they kept on moving around the road quite aimlessly, just like the ant, and their skin was black, and it was so much scaled that it was something like an alligator skin. That is why this term ant-walking alligator came into play. The people who were quite close to the epicenter and in the outside, they were immediately obliterated. Those who were close to some kind, those who were indoors, but close to some kind of window which was facing that epicenter, they also had the same fate. Those who were inside and was not facing that kind of in that epicenter, many of them survived, but with several incidents or several marks of radiation. Like those who were wearing dark color clothes suffered strong effect, those who were wearing white colored clothes were in a slightly better position. There are several photographs where you can see persons who were wearing some kind of striped cloths, that particular stripe got printed on their skin. Some people were completely vaporized, leaving behind nothing but a shadow. We know that whenever some kind of radiation, just think about maybe light. When light is coming from some source to towards us, then it will create a shadow. Shadow basically refers to a zone where light was not able to reach because of our presence. The similar kind of thing happened here because of the strong radiation effect. When some person was in the line of that strong radiation effect, it created a shadow of that person in the associated or in the near location, maybe on the floor or on some kind of wall, but the radiation dose was so strong the person completely vanished, leaving behind the shadow. The patterns from clothing that I just have mentioned, which is burned to skin. Dried husks of human beings. Dried husk refers to the temperature was so high because of the explosion that the entire blood from the human body evaporated, leaving behind something which resembles just dried husk. Also, lots of people also did not die just a result of the radiation, rather lots of people died because of the huge storm or huge explosion that happens, because of which lots of trees were uprooted. There was pictures, one 300-year-old camphor tree which was uprooted, and then things were blown away by strong air, and lots of people died by collision with those kind of trees and other heavy things which were blowing with the air. Some people were blinded instantaneously, some other took years to lose their sight. Surrounding environment were devastated by black rain, and the long term effect of course lasted over generation, which is the biggest concern in relation with nuclear. Of course, whenever there is a bombing in some location, there will be severe effects, but that effect again will be limited only to a short instant of time. But related to any kind of nuclear accidents or such kind of nuclear weapon use, the radiation effect will last there over extremely long periods. And this particular image is synonymous to the Hiroshima. There are lots of wristwatches were found which stopped around at 8:15, the time when the incident struck there. So, but in a nutshell, we are discussing about, or I am mentioning about all these incidents just to show you what effect radiation can have because of the use of nuclear weapon. And now let us come to nuclear power generation. The use of nuclear energy started from that 1945, and it started with such an incident that from the very first generation of nuclear power generation, nuclear power plants, scientists were very much careful about the possible hazardous effect radiation can have and what can be the possible implications of a nuclear accident. And therefore, different safety measures were taken from very early generation plants itself. Still, there were quite a few, actually I should say there are 3 quite prominent nuclear accidents which happened over last 65-70 years of nuclear history, and each of those accidents had different reasons which allowed the scientists to go back to the fundamental designs and find what are the sources of those or reasons behind such kind of accidents and come up with some kind of modified and improved design. And the first one of them was the 3 Mile Island incident. It was a small island, a small river island of United States. The location is shown here. This is schematic of their plant. Now, seeing the schematic, can you say what kind of reactor it was? Yeah, you are correct. You can see there is a pressurizer. So, it has to be a pressure water reactor. It was a pressure water reactor, pressurized, I should say it was a pressurized water reactor or PWR, which the schematic shows all the standard components of PWR. The incident happened on the second unit of this particular plant on March 28, 1979 early morning. Some minor malfunction that caused the second reactor to shut down almost immediately, and a relief valve which was supposed to close, but it was it did not, contrary to what the instrument panel showed. In fact, some studies it also showed that one light which was on the instrumentation panel that lit following indicating that the relief valve is still open, but the operator who was there, he misunderstood that symbol and assumed that everything is normal, the valve is working perfectly. The result was when the accident starts, the operator struggle to determine the problem, and once they do not know what the problem is, they can't find an appropriate solution as well. So, the situation, it took quite some time to get the situation under control. Luckily, there are not too many common people around the plant, and it took around 16 hours and a consistent effort of 60 or more number of persons to get the situation under control. There were human factor that I must mention about the reason behind this accident. Critical human factor and user interface engineering problems were the primary reasons behind such an accident. The valve was being stuck open, with light on the control panel ostensibly indicated that the valve was closed. But as I have mentioned, in some cases it is also mentioned that the operator misunderstood the symbol that the light was giving. The light did not indicate the position of the valve, only the status of the solenoid valve being powered or not, thus giving false evidence of a closed valve. And because of that, the operators failed to diagnose the problem for several hours, and such kind of incident has happened that came to know only after quite a few hours, when the situation started to go out of control. The operators probably were not properly trained to understand the ambiguous nature of this pilot operated relief valve indicator, and also they were not properly informed, or they did not have proper experience to look for alternative confirmation that the main relief valve was closed. There is a temperature indicator downstream of the pilot operated relief valve in the tailpipe between the relief valve and the pressurizer. That could have also given the indication that the valve is open, that the temperature in the tailpipe should remain higher than it should have been if the relief valve was shut down. But the temperature indicator was not a part of their suite of indicators designed to be used after an accident, and therefore, the operator did not know how to use that symbol or how to implicate that particular symbol. Its location on the back of the 7-foot high instrumentation panel also meant that it was effectively out of sight of the operators. So, the principal reason behind the TMI incident, TMI means 3 Mile Island, we can summarize as: number 1, proper training of the operators. They did not have any idea about how to implicate the signals given by different sensors. They did not have any experience of, or they are also not properly qualified enough to decide what action to be taken against an unknown or new kind of incident. Number 2, the failure of that relief valve, and also corresponding wrong signal given by the instrumentation panel. Number 3, improper design of the instrumentation panel itself. All the indicators were not properly placed. This. Number 4, the lack of any backup option. Like, once the relief valve was kept open or it was stuck, only one indicator, the plant was dependent on only one indicator to show that the valve is open or closed. But the other symbols, like other possible options of indicating the same, like the temperature indicator we are mentioning here, those things were not part of the safety panel, and so there was no backup option corresponding to each such kind of signals. So, it is grossly, you can say, a negligence from the part of the designers or the lack of experience from the part of the operators, which led to such kind of accidents. And this was the situation of the reactor core after the incident happened. Now, the health effect, of course, the government tried to suppress that incident. They claimed that there are no injuries or adverse health effects from accidents. Only one additional cancer death from radiation absorption resulted within 50 miles of the plant, but later it was found that there is an increase in the infant death. Also, it was increase in babies, increase in the number of babies born with hypothyroidism, which was the result of the spreading of radioactive iodine and cesium isotopes into the surrounding areas. Till about late 1990s, no peer reviewed article was present which provides reliable data about the rate of cancer or other effects in the post TMI era. The amount of contamination was quite significant. Some radiative gases and also hydrogen are released to the atmosphere. A maximum of 13 million curie amount of radioactive gases were released to the surrounding. That was a quite significant number at that point of time. The maximum doses to a person at the side boundary was found to be less than 100 mrem. During the cleanup operation, it took nearly 12 years to clean everything. The cost of cleanup was estimated to be about $973, about $1,000 to get the cleanup, and during the cleanup process again several workers were contaminated with the residual radioactivity, and the plan didn't reopen till about 1985. Now, what was the effect of TMI on nuclear industry? Of course, there was effect, there was radiation spread to the surrounding areas, but the effect of radiation was not that much because it was not situated in a highly populated area. Rather, as you have seen earlier, it was a river island, and so apart from the workers or people associated with the plant, there are not too many common people around, but there was a significant effect on the growth of the nuclear industry. As you can see from the first graph, the total installed capacity kept on increasing quite rapidly, and suddenly somewhere here it found a halt. This was active reactors, refers to active reactors, which also kept on increasing, and there are additional construction that goes on. Again you can see the volume of this additional construction, like it was something like this amount here, whereas around 1975 it was like this amount. So, it also kept on increasing, but suddenly there is a decrease following this 3 Mile Island incident. In this zone there is sudden decrease in the capacity addition. And then something that we are going to discuss, the Chernobyl accident happened in 1986, and following that there is almost a saturation in the nuclear industry. There was hardly any new construction that goes on since that period of 1986 to something like 2005. So, total realized capacity or installed capacity that also got stalled, and there are hardly any new growth in the nuclear industry. Following the 3 Mile Island incident, the number of reactors under construction in US declined every year from 1980 to 1998, and many Babcock-Wilcox reactors, which was the primary supplier of nuclear reactor that time in United States, that were cancelled. In total 51 nuclear reactors order, or 51 orders for nuclear reactors were cancelled between 1980 to 84. So, there is a huge shake up to the nuclear industry in United States, to be particular in during the 3 Mile Island incident. But in other part of the world there were not big effect, particularly in European countries till this period. Like if we see from the graph, 3 Mile Island happened somewhere here, and but still over this period of something like 7 years, from 1979 to about 1986, the total installed capacity kept on increasing sharply. And while United States were started to shut down their plants or stopped any kind of new constructions, European countries continued to increase their installed capacity. But then we reached 1986 when we had Chernobyl incident. Chernobyl was a nuclear plant located in present Ukraine, which was a part of that time it was a part of the USSR. This was the reactor core. From the reactor core, can you get any idea about what kind of reactor it is? Let me see from the picture. You can see water is flowing around. So, it is a water cooled reactor, light water cooled reactor. No other information is given, but okay. Then let me add, it was a light water cooled reactor or LWR, but the moderator that was used was graphite. It was quite odd combination. In module number 7 we have discussed about different thermal reactors. So, from there can you identify what kind of reactor it was? It was a graphite moderated water cooled reactors. So, LWGR or called RBMK. That time RBMK reactors were extremely popular in USSR, and almost all nuclear reactors, active nuclear reactors in Soviet Union were of RBMK type. The incident that happened in I think there is the 6th unit of Chernobyl. It was April 26, 1986. Sorry, it was the 4th reactor. It also happened again in very late night, around 1:23 am. It was not because of any faulty design, rather it was because of wrongly planned or very poorly planned experiment done by the operators. The RBMK design had its own fault, but till that moment all the RBMK plants in Soviet Union were operating fine, and so there was some sense of overconfidence by the operators, which led to this particular situation. They are doing a late night safety test on the reactor 4. The test started on April 25, but because of certain issues it was delayed to this late hours, and they are trying to simulate a station blackout power failure, in which during that experiment, as a part of the experiment, all the safety systems were intentionally turned off. So, the system was system didn't have any kind of safety system under operation at the time of this experiment, which was the first major mistake that they made. Because of some inherent reactor design flaws and the reactor operators who didn't follow the proper procedure while doing the experiment, that led to an uncontrolled reactor operation. You probably remember that RBMK reactors, one big problem with their initial designs, like the one in Chernobyl, the initial design had the problem of positive void reactivity feedback, which leads to an unstable reactor, and that is what happened. As the reaction went uncontrolled, it resulted in destructive steam explosion and subsequent open air fire, and that fire lasted for about 9 days. Uranium fuel got overheated and melted through the protective barrier of the reactor, releasing radioactive fission products to the environment, and also the fire was so strong that it created a very strong updraft, thereby creating high velocity movement of air around the plant. And as the fission products were emitted to the plant by the melted uranium fuel, they were carried by strong air to all the neighboring areas, particularly in all areas of Ukraine and Belarus, or most part of Ukraine and Belarus, the presence Russia, and even in some parts of Western Europe. This picture shows some of the affected areas. You can see even countries like Romania, almost entire of Hungary, that was affected by this radiation effect. Now, Chernobyl accident is only one of the 2 nuclear energy accidents classified as a level 7 event on the international nuclear event scale. The second one, can you guess what is the other one? Chernobyl is the first one which got a level 7, and actually level 7, I must mention, is the highest level on the scale. The other incident that happened in 2011, yeah, I think you can guess now. It was the nuclear accident that happened in the Daiichi power station, Fukushima, Japan. That was also a level 7 incident, but there the reason was something else. And there nature played a big role, because everything was initiated by tsunami. So, from that point of view, this Chernobyl is often termed the biggest man-made nuclear accident to have struck the world. The biggest man-made nuclear incident that happened in the world. Initially, only 2 persons died in the facility following the explosion. One died almost instantly, which is quite surprising, because despite such a huge amount of explosion, only 1 person died on spot, and the other died later due to deadly doses of radiation. 134 people are hospitalized with acute radiation symptoms, of which 28, which includes firemen and employees, died in days to months afterwards from the effects of active radiation syndrome. One big mistake rather, was made by the authorities and even by the government also. They failed to realize the difficulty level of the situation, and therefore decided to ignore it virtually. And this sent firemen and also several other construction workers to go to the site, rescue workers I should say, to rescue the common person and the plant itself. Approximately 14 cancer deaths among this group of initially hospitalized survivors were to follow within next 10 years I should say. This is data from 1996, so it might have increased by now. An excess of 15 childhood thyroid cancer deaths has been documented as of 2011. 600,000 more are involved in firefighting and cleanup operations, and they are exposed to high doses of radiation. As per official records, over 84,000 people in Belarus, Ukraine and Russia were exposed to the radiation. So, just by seeing these numbers, you can get an idea about the magnitude of the event. I repeat, this is called the largest man-made accident in the world. This particular bridge, this is a new picture. It is there was a small town called Pripyat, which was just about 3 miles away, located 3 miles away from the plant, having a population of around 50,000 that time. In the early morning of that fateful night, they heard the huge explosion and rushed to the Chernobyl plant, and on their way there was this particular bridge which was just about 1.3 miles from the plant. So, they stood on the bridge to see what is happening. So, they waited on the bridge and saw the entire incident, but they did not have any knowledge that they are getting directly exposed to very high doses of radiation. Later on, a medical investigation estimated that the contamination on that bridge, the contamination level on that bridge was 8 times higher than what is required to kill a human being. There are no study was done later on to understand how many persons from this particular town died as a result of this incident, but this bridge has been named as Pripyat bridge of death. These are the contributions from different isotopes. As you can see, certain isotopes die down quite quickly, like iodine 131, which is a big contributor towards thyroid. Because of its short half life, it died quite quickly. This is another one which died even earlier, just to less than 100 days. This is tellurium 132, but certain isotopes continue to have a much longer lifespan, like zirconium 95 is continuously increasing, and then this starts to decrease because there may be certain work with the it increases initially and then it decreases because it gets produced during radioactive decay of certain other isotopes also, but most interesting of them is this particular one, which refers to cesium 137. It actually keeps on increasing, and even after a period of 10,000 days, it is extremely high, and it contributes about 100% of the radiation level. So, this is a very long living isotope, while others have almost died down by now, it is still very active. This is another figure which was taken from a study done by medicine practitioners, that which reflects the increase in the thyroid cancer among child and adolescent from Belarus after the Chernobyl incident. Here the vertical axis represents every 1000 incidents, 1000 such cases, and you can see around 1986 when the Chernobyl incident happened, it was quite small, but it kept on increasing rapidly. For the red line refers to the children, it increases and then again drops down by 2002. The yellow line for the adults, it keeps on increasing quite sharply, the same in the adolescent period as well. And certain isotopes like this iodine 131, this cesium isotopes, they are strong contributors towards this thyroid cancer, and therefore, they are still very much active and in that Chernobyl and surrounding areas, and leading to the appearance of this thyroid cancers. On the nuclear plant construction procedure, we have already seen one picture earlier following TMI, and look at this, the TMI happens here. After that there is a decrease, and now this is Chernobyl, and following Chernobyl over this entire period hardly any new construction happened till about 2006, 2007, and then it has started to increase, but still quite random, because in this period of 2011 to 2015 it is quite small, and this is a global picture, not for any particular country. So, following this Chernobyl incident, there was a huge lull in the nuclear industry, as people are very much apprehensive about using nuclear power for commercial power generation, just with the fear of having the repeat of another Chernobyl. But as time goes on, over this big lull period of about 15-20 years, scientists have came up with newer designs, the concept of generation 3 or generation 3 plus or even generation 4 nuclear reactors, which came up with newer designs of nuclear reactors with enhanced safety features, and so then it has started to increase again the total nuclear plant construction. Finally, the lessons that we have received from TMI and Chernobyl, I am not mentioning about Fukushima here, because the conclusions will be quite similar. The two primary lessons are related to emergency preparedness and response and transparency in the procedure. So, if under emergency preparedness and response, prompt notification is absolutely essential, which can be tested by the protective action. Exercise, all such kind of exercise must happen with complete collaboration with both local and regional officials. because the absence of regional officials was one of the reason of this Chernobyl incident. Local authority didn't have proper idea about what's going on, and therefore they failed to evacuate the site. Multiple units, there needs to be question answered before setting up multiple units, and again what can be the option, what can be the emergency response in case of any kind of terrorism attack, which is becoming increasingly relevant nowadays. And other aspect is transparency. Safety analysis and design must be done, and the results should be made available to the concerned authorities. Then the proprietary information, security information should be made public. Basis of decision should be made known to everyone, at least to the knowledgeable persons, and place regulatory documents and plans on the web for stakeholder contribution. So, with all these lessons, now we finally come to the safety objective. So, the fundamental safety objective of a nuclear power generation is to protect people and the environment from harmful effects of ionizing radiation. This is the paramount sentence or paramount objective that any nuclear plant designers should keep in mind. No way the effect of ionizing radiation should reach the human being and the environment. And the newer generation, generation 3 and particularly generation 4 spend lots of time, lots of effort during the design to ensure complete contamination reduction or complete isolation of the ionization radiation. To achieve this objective, nuclear plants are designed and operated so as to achieve the highest standard of safety that can reasonably be achieved, which includes the control of radiation exposure, controlled it should be controlled release of radioactive material to the environment, particularly during the waste disposal procedure, which we shall be discussing next week. Restrict the likelihood of an accident with inadvertent release of radionuclides. Mitigate the consequence of such an accident, means what can be the possible types of accidents that we have to foresee and we have to be prepared for that. Important elements of nuclear safety are the principle of defense in depth and the definition of application of safety functions. So, defense in depth is the name that is given to the safety features which are used in modern nuclear power plants, and this one we shall be discussing in the next lecture. So, I would like to finish today's lecture here itself. Today we have discussed about quite a few grim topics, the sad incidents that happened in Hiroshima and then the nuclear accidents in 3 Mile Island and Chernobyl, but I mentioned about all these incidents just to make you aware about the importance of having safety in a nuclear power station. This is something that is of paramount importance, and believe me, at the very first step of design, when the design of a nuclear power plant starts, the first thing the operator or the designer starts to work with is the possible safety barriers that they are going to put in, which falls under this defense in depth. We shall be discussing this in the next introduction. So, thank you for now.